Lesson 4.4 is on scientific notation, and you will be expressing numbers in standard form and in scientific notation, and comparing and ordering numbers written in scientific notation. Remember, the essential question for Chapter 4 is, why is it useful to write numbers in different ways? Well, in this case, scientific notation represents really large numbers and really small numbers. And so scientific notation is very useful to cut down on the number of zeros that you have to write out for these numbers. So on your note sheet, you don't have this key concept. However, you do have a place to fill in some notes on your sheet on what does it mean to write a number in scientific notation. So numbers that do not contain exponents are written in standard form. However, a number that is expressed as a product of a factor and a power of 10 is written in scientific notation. So here's your factor. Product means a multiplication problem, and then a power of 10. So it will always look this format. The exponent can either be a positive number for really large numbers, or it can be a negative number for really small numbers. So we are going to take a look at the example on page 153. When a number is written in scientific notation, we can easily put it into standard form by moving a decimal the number of places of the exponent. So that's going to be our key here. If the exponent is positive, we're going to move the decimal place to the right. And if the decimal is negative, if the exponent is negative, we're going to move the decimal to the left. Okay, and just to show you that that's just not some made-up rule that we're just trying to make you remember, remember that negative exponents are also written as fraction as 1 over that fraction or that number to the positive exponent. So 10 to the negative 4 is really 1 over 10 to the positive 4, which is 1 over 1,000. Okay, and 1/1000th times 3.12 is 3.25 divided by 1,000, 325 thousandths. And so 3.25 thousandths. And so when we move that decimal over 1, 2, 3, 4 places, what we get is 0.000325. So the easier way, of course, is just to move the decimal to the right or to the left, depending on the exponent. But just so you know, there is proof to why that actually works out. In the Got It section, go ahead and do those problems, press pause and work them out on your sheet, and then you can come back and press play and make sure you have those correct. For 1a, you should have 400. 4 times 10 to the second power is 400. In 1b, you're going to move the decimal over 7 places, so you should have 594 with another 5 zeros, 1, 2, 3, 4, 5. I can just turn my answers on so you can see this a little bit better. And then you go ahead and put your commas in, and what you have is 59,400,000. In 1c, it's a negative exponent, so we're going to move that decimal place 1, 2, 3 places to the left, and then you're going to fill in zeros for those empty spaces. So it's 0.0013. At the top of page 154, we have example 2. And in example 2, you're writing a expanded form or standard form number into scientific notation. And this is where it's really important that you understand that scientific notation is always written in the same format. That first number always has to be greater than or equal to 1 and less than 10. Okay, so we're going to use that in just a second. It's always going to be times 10 to a power. Okay, and even though I said we really don't use that x anymore for multiplication, that is the most common way you'll see scientific notation written out is with an x. So in 2a, we have 900. We have to put a decimal somewhere in this number to make it greater than 1 and less than 10. And if I put it here, that's 0.9, and that's less than 1, so we can't do that. If I put it afterwards, we're going to get a number less than 10 and greater than 1, so that's what we want to do. So it'll be 9 times 10, And then how many decimal places would we have to move it over to make it 900? 1, 2. So it's 9 times 10 to the second. Okay. For 2b, I can't put a decimal here because 0.189 is smaller than 1. But if I put the decimal right here, I have 1.89, which is greater than or equal to 1, but less than 10. I couldn't put it after the 8 because 18 is greater than 10. And then times 10, because that's always what it's going to be for scientific notation. Now we have to count 1, 2, 3, 4 places. So their exponents is going to be 4. On 2c, it's a really small number, so I know this is going to have a negative exponent because really small numbers are going to be having negative exponents. So I got to figure out where to put the decimal in 64 to make it greater than or equal to 1, but less than 10. I'm going to write that as 6.4 because 6.4 is greater than or equal to 1 and less than 10. Now I've got to figure out how many decimal places. 1, 2, 3, 4, 5. And since I move that to the left, it's going to be 6.4 times 10 to the negative 5th power. Again, there's a video tutor for you to watch. There's also a BrainPop video that you're going to be watching for this lesson. It's really a simple concept, but it can get confusing when you throw all of it together. For example 3, you're going to be doing some more scientific notation, and it says to estimate. Okay, so we have 3,612,500, and there's not really a wrong answer here on how you estimate it. So what they did in the answer key was just estimated that to 4 million. So that's 4 times 10 to the 6th power. Okay. In 3b, they estimated 251 to be just 3. And the decimal would be 1, 2, 3, 4, 5, 6, 7. And because they moved it to the left, it's a negative 7 power. Finally, 4.215 is really close to just 4, so they rewrote that as 4 times 10 to the negative 3. On your note sheet, you have a couple more problems that I stole from the algebra textbook, and they're just really simple, just like what we've been doing. This one right here, 68, that would be billion. So we're going to write that in scientific notation by placing a decimal to make it greater than or equal to 1 and less than 10. So that would be 6.87 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6.87 times 10 to the 10th power. On this one right here, placing the decimal between the 7 and the 2 would make a number greater than or equal to 1, but less than 10. So it would be 7.25. And we have 1, 2, 3, 4, 5 decimal places to move it to the left. So it would be 10 to the negative 5th power. 7.25 times 10 to the negative 5th. On this one right here, we're just going to move that decimal over to the right 6 places. So we'd have to add 3 more zeros. That would be 3,201,000. And then on the bottom one there, we'd have to move the decimal place 5 places to the left and fill in 4 zeros. So 0.0000903. Don't forget to watch the BrainPop video. That's a good one to go over this concept of scientific notation. You also have level K, lesson W1 for IXL at 90%. Don't forget to take your self-check quiz and email me your score, and your worksheet for extra practice will really help you understand scientific notation.